Remember like a year ago in the before times when we thought the Australian wildfires in January of 2020 was gonna be like the worst part of 2020? Do you remember what it's like to be that innocent? Hey team, I'm Maddie, welcome to Science Sci It Up, and today we are talking about the connection between climate change and wildfires. Believe it or not, we are wrapping up this series on climate dynamics. I think there's gonna be this video and then 2 more. And what I wanna talk about in these last few videos are some of the concrete, tangible effects of climate change that we can see happening right now. And then we can talk about why those are happening in the context of everything we've learned in the last 17 videos here in the Climate Dynamics series. So we're gonna start with wildfires, specifically in California and Australia. Y'all know by now that global warming isn't going to affect everywhere on planet Earth in exactly the same way. And one of the ways it's gonna affect specifically Australia and California is going to be an increased frequency of wildfires. So why might that be, you ask? Great question. Let's take a look at my handy dandy inflatable globe that's conveniently right off camera to understand why. Okay, so here is our handy dandy globe. Here is the equator. And then if we're gonna look up 10, 20, 30 degrees latitude, bam, right about there, right? There's 30 north, so we're getting into that Baja California and Southern California area. And then if we look over Southern Hemisphere, Australia, here's the equator. Here is 10, 20, 30. If you guys remember from when we talked about the Hadley cell, we said that we would expect to find global regions of desert corresponding with the descending leg of the Hadley cell. And that would be at right about 30 degrees north and south. So those are desert regions, right? We know that Australia, Southern California, those are desert regions. We also know that warming the planet is going to strengthen the Hadley cell. So what does a strengthening Hadley cell mean to you and me and to those regions? Excellent question. One, it means that its poleward extent is going to increase. So if before it reached to 30 degrees north, right, it's gonna start reaching further and further north in California, further and further south in Australia, because Australia is in the southern hemisphere. So it's going to start to move towards the poles, the descending leg, and a stronger Hadley cell is going to mean that we get more convection at the equator. So around the equator, we'd expect it to be even rainier than it is now. But on those desert regions, on the descending leg, we would actually expect the air to be even drier. So not only are we gonna have that overarching descending air reaching further than it did before, it's also going to be even drier. So these regions that are already prone to drought are now more prone to drought. What does all of that have to do with wildfires? Well, if we're talking about what things make a wildfire sort of probable, what factors do wildfires depend on? They depend on the temperature of the region, the soil moisture content, and they're going to depend on the existence of vegetation or stuff to burn, right? So the warmer you are, the drier your soil, and the more stuff to burn there is, the more likely a wildfire is. What does that Hadley cell intensification do? Well, we're gonna get warmer air, less moisture, so drier soil, and as it's starting to move, extend the reach of the Hadley cell. So we're going into regions with lots of lush vegetation, so lots of stuff to burn. So what we would expect to see is the frequency or the probability of wildfires, specifically in like central and northern California, and in Australia it would be more southern Australia. That's where we're gonna expect to see the probability of wildfires go up. Is that what we see? Well, please enjoy this graphic, which is, this looks at instances of wildfires in different regions in the United States. And I want you to draw your attention to that light blue region in central and northern California. And lo and behold, not only are wildfire instances increasing in this entire region, but they are specifically increasing in that region that, just by thinking through the Hadley cell, we predicted we would see increased wildfires. Hey team, Editing Maddie here. I did just want to take a quick second to point out that in that sort of coral-ish color that is like Southern California, there is a very slight decrease in the instance of wildfires in this region. I don't know why exactly that is off the top of my head. When I was looking at this, I was looking at sort of the region we were interested in, that light blue Northern California. But I did just want to go ahead and point that out. While the overall trend is increasing wildfires and the trend in the region we predicted increasing wildfires, there is a small region where there is decreasing. For wildfires in California and Australia and places like that, and for desertification of these regions, plus the Sahara is definitely a region we would expect to see desertification. Those connections with global warming and climate change are not only pretty darn easy to predict and understand, they're also, that is what we see happening when we look at the data over the last, say, 30 years. While it is almost impossible to say that like this specific wildfire is the direct effect of global warming, what we can say is that probability of wildfires going up is predicted by climate change, and that is what we see. Okay team, that's all I've got for you today. I hope you and those you care about are well. There is a link in the description to a buy me the coffee fund if you are willing and able to financially support my science communication habit. Otherwise, please subscribe, be kind, and I'll see you all next time. Bye team!